I will talk about the possibility of evaluation of research, financing of scientific research, and at the end I will talk about the research and excellence in research at our university. About the importance of the scientific research in universities. In many countries, for instance in the United States, as far as I know in Hungary and some other European countries, the name university is used only for higher education institutions with an important scientific research activity. And typically, university in most of the countries must offer doctoral studies. Well, in Romania this thing is not regulated yet. I was looking just 2 days ago at the website of the Ministry of Education, and I found there 56 state universities and 50 private universities, and all we know that many of these universities has no important research activity, mainly some private universities. So, you should know that in Romania never was made a ranking of the universities, so we have more than 100 and there is not any ranking made. Okay. But all we know that research is very important in the higher education institution. But why? Well, we know that the goal of any higher education is to educate students with creative thinking. So we just do not want to give them some knowledge, information. They need to develop this creative thinking. And as we know, the best training for creative thinking is scientific research. So scientific research is not just because of the sake of the research and the outcome of the results, the scientific results of this activity, but is very important also is in education. Without the world-class scientific research of the teaching staff, students cannot get the education needed for an innovative, knowledge-based society. Well, our rector, Professor Marga, told about the rankings of the universities, and we know that the so-called Shanghai ranking takes into account only results in scientific research. So they take into account the number of published papers, the scientific awards such as the Nobel Awards, the citations of the papers and so on. But this is the only thing what they take into account. Some other rankings such as Times and the QS ranking have a more complex methodology, and I think that all of you are aware of this methodology. An important part of this methodology is the academic peer review, taken into account by 40%, the number of international students, and practically research excellence is taken into account just by 20%. But interesting is that the top universities in the Shanghai mix are also at the top in the Times and QS ranking. So there are some small differences, but the order is more or less the same. So if we look at the scientific research at the university, and that has high quality, that university will have also a very good evaluation of academic peer review. So these reviews are usually based on the results of scientific research. Those universities will have a lot of international students and so on. Okay, how can we evaluate the research? Well, the research publications, citations, such as in the Shanghai list, and sometimes is taken into account the attractive money, the obtained grants of the teaching staff and researchers from the university. We can put the question, is this enough? So if somebody publishes and attracts money, is this enough? And put here, is this the same topic that Professor Marta also thought about? That practically the ultimate reason for cultivating science should be the practical application, resulting in improving life quality. And all of the researchers and university staff know that a large percentage of the published scientific papers will not have any practical application. But do we know which scientific discovery will have practical application in the next 10 or 20 years? No, we don't. How can we determine which one will have practical application? Evaluation of the possible outcome is very difficult. And the evaluation of the science in history was so that there are a lot of scientific discoveries, and some of them will have practical application and some not. But fundamental scientific research is very important. Well, and I have put here the question that can a society invest just in research with a certain measurable benefit? How effective is this so-called goal-oriented research? So, let's say we want to obtain a smaller mobile phone. Okay, that is the goal, and we want to obtain it. But I am sure that without fundamental research, we won't have the basis of these new discoveries. So, this goal-oriented research may lead to results for the applied research, where the fundamentals of the field are already known. And the goal is just some improvement. You know? But in case of the fundamental research, in most of the cases the results and their applicability is unpredictable. Many scientists say that the curiosity-driven research, which is another word for the fundamental research, may lead to surprising applications proven by the history of science and technology. And here I have took a slide from the Nobel lecture of Theodor Hensch, who got the Nobel Prize in Physics in 2005. And he said there that sometimes curiosity-driven research leads faster to the result than the goal-oriented research, when you practically put up a goal and but you do not have all the support for that in let's say basic scientific knowledge. And of course we can say a lot of examples for this. I'm a physicist, so I can give better examples in physics. For instance, the positron, the anti-particle of the electron, was discovered in 1932. Nobody knew then what is the use of this particle, or so it will be any practical application. In the last 20 years, it was developed the so-called positron emission tomography, which is one of the best method for medical applications, so for medical diagnosis. So you never know, you discover something and it will be used after 20, 30, 50 years. So we need, I think, and the Nobel laureate said we need also the more simple. Why? Because private companies are willing to do it because the benefit and profit and practical applications are predictable and close. And it is a very simple example. If we want to do cars with more powerful engines and with less consumption, this is a goal. We know all the fundamentals of the thermodynamics and physics which is needed for the function of the engine, but we can do some improvement. And this applied research is very well financed in the developed countries. And in the developed countries, more than 50% of the science funding is coming from private companies, but this is practical applied research. And you see here, in Japan is very important, the business, the funding of research and development by the business sector, so this upper part. Also in US, well, in Europe is a little bit less, but Europe, of course, the European Union is large, and we have different countries. In Sweden and Finland is higher than in Japan, and in Greece and Romania it is much lower. So this is the EU average. But of course, private companies are not investing in any field. They invest mainly in transport equipment, as I told you, cars. They invest mainly in ICT sector, computers, mobile phones. They invest in chemicals and pharmaceuticals, and the rest is just one quarter. Nobody will invest in order to find a new particle, and nobody will invest in order to find a new supernova in the universe. No? So no private company will invest in such a kind of research. They invest in the fields where they can see their money in 2, 3, 4 years. Okay, what about who will fund the curiosity-driving research? In any state, the fundamental research is typically financed from public funding, government funding agencies, and so on. And sometimes, some people, taxpayers, citizens, the question, why should taxpayers pay for satisfying the curiosity of some scientists? Why should we finance this activity? And why should someone invest in scientific research if the only outcomes are just scientific papers and maybe books? No? What is the reason for this? And I have just read a debate on the webpage of the Science magazine, where in the United States, a guy, a lawyer, said that the state should not finance at all the research, because he says it is anti-constitutional to use the taxpayers' money for finding the Higgs boson or exploring the universe, because it does not lead to public good. That is his argument. Fortunately, of course, there was a debate, and many scientists replied and explained why fundamental research is important. And fortunately, also in the United States and developed European and Asian countries, the state funding of fundamental research is quite high. So it is more than 1–2% of GDP in these developed countries. Well, in Romania, 2–3 years ago, the situation was acceptable, but now I can say that the government does not give much importance for supporting science. The research funding budget was cut to less than half in 2009–2010 because of the financial crisis. So we lost more than half of the the results in fundamental research, which can be measured by scientific papers, citations to the scientific papers, and the investment of private companies in research. Here you see a graph with the business research and development intensity. So how much business invests in research. This is the number of researchers per 1,000 total employment, and it is separately which one is the business sector and which one is the public sector. You see, for instance, in Finland, just more than half of the research is done in the business sector, while in some other places, such as in Greece, for instance, a very small part, but the state financing still exists. But the same countries, more or less the same countries, are in front in the citation impact of the published papers. Those countries which invest much in research, it can be also the business sector for applied research, the same countries are good in producing scientific papers and cited scientific papers. This graph was taken from a report by the Academy of Finland about the state and quality of scientific research in Finland. Finland is a very good example in Europe because it invests a lot of money in science, both in public and business sector. And from the same report, I have put another image which talks about the fact that, well, science is important, and we can measure the science in published papers and so on, but science and technology have placed increasing focus in recent years on the requirements of efficiency and impact. And I copied from this report this impact framework, where the Finnish Academy has put here the goal of the Finnish society. So that is GDP growth, improved knowledge, know-how and competencies, achievement of well-being, and improved condition of natural environment. This is the goal. But what should be the inputs? Material and human resources, existing knowledge and know-how, innovation, and foresight. And within the activities, education is very important. So if we want to have a country with high GDP, improved knowledge, improved condition of natural environment, many things are important, but education is one of them. And you know that Finland invests much in education. They have one of the best education system in the world. Okay. Of course, university research is important, as I have talked about this. But sometimes, just like in Romania, the state funding of research is not enough, and it would be desirable the support of university science and research also by industry and private companies. However, university research is typically financed by the state, and I have put here a graph from the United Kingdom because, well, in Romania the industry and the business sector is not very developed, but also in the United Kingdom with a strong industry, the research funding by industry we are the first. However, on an international comparison, we know that we need important improvement of our scientific research. We are not in the first 500 universities of the Shanghai ranking. They say that we are at about places 700. So at the international, in the international comparison, we need a lot of improvement. And as also our rector said, improvement is needed both in fundamental research, measured in number of papers and citations, but we need probably also applied research, measured in the partnership with industry and so on. My colleague Vice Rector Marcus will talk in more detail about the excellence program in the Babeş-Bolyai University, because this year the BBU has done the program for obtaining and establishing excellence in several domains. I will talk just about the excellence in scientific research groups. The criteria for the excellent scientific research groups were the relevant publications, books, articles, patents, organization of important conferences, and our rector great deal on the technological impact of scientific research, fund effective from industry, and some other things. So, as I told, the university and colleges, beside the fundamental research, also the applied research. And after the evaluation, there have been awarded excellence title to 32 research groups from the university, and practically, by this excellent program, we want to improve our fundamental and applied research also in the international competition. Well, at the end, I have put just one conclusion of mine, that scientific research should have measurable benefits also to public good. However, here I have put another conclusion, not my words, but words of a Nobel laureate physicist who talked about physics, but I think that this statement is valid also for science. He said, Richard Feynman, physics is like sex. Sure, it may give some technical results, but that's not why we do it. So, you can choose both. Thank you.
Thank you very much, Professor Nagy, for an inspiring paper. Perhaps time for just a quick couple of questions. Yes, please.
Gathering information for this presentation, I guess, was practically research. Now, if you were an important investor and you would want to invest in something, what is the sector that you would choose? And in what country? Thank you.
Well, I am not an investor. It's a hard question.
Let's assume that if you would be
Of course, it is understandable. An investor wants to get back his or her money in a relatively short time, and of course, I would invest also in applied research with some immediate applications. My point here was that we need also fundamental research, so the state should give money for fundamental research because it is important. We do not know when, maybe in 10 years, maybe in 20 years, maybe in more. But we cannot stop the fundamental research, but it is understandable that the private sector invests in applied research.
Thank you very much. Is there one last question before we move on?